Hi, my name is Bernadette Grantham, and this is my Lab 2 magnetic field of a bar magnet. In this lab, we were trying to understand how the distance from a magnet affected the magnetic field of a bar magnet using a magnetometer, and to better visualize the magnetic fields. We used the PHYS of our lab to calculate the magnetic field of a dipole and to find mu, which is that law is to the right, and we used the bar magnet distance dependence equation, which is also to the right. So for this experiment, we had to get a magnetometer and a bar magnet. That was kind of the only two initial setup. And then we had to find the magnetometer chip. So we slid the phone perpendicular to a ruler to find the place where the magnetic field was strongest. And there's an example of this on the top 3 pictures. And we had to find the on-axis magnetic field distances. So the ruler was used to measure the on-axis distances from the phone to the bar magnet. Then we had to graph the data and linearize them by taking the natural log using the equation to the right. And then we had to find the off-axis magnetic field of the bar magnet. So to do this, we placed the phone at a distance in the negative x direction where the B field was 100 microteslars, and then we slid the phone in the y direction by the same distance. This is shown in the picture in the bottom right corner. Some of the calculations we did was we did the distance dependence, which we did y is equal to negative 3.01 times negative 14.598, and we used n, which is equal to the slope, was 3.01. That's how we got that number. And then the natural log of k was negative 14.598, and k was positive 4.57 e to the negative 7. So for the PHYS law, we used r is equal to negative 1 meter, and then mu naught was 2.285 amp meters squared. So this basically just shows some of the data that we found. We found the different distances as shown in the tables at the top, and then it found the average for us, and then we linearized that, and that's what gave us the graph. And then we, on the bottom things, that was for the off-axis field, and just some of the numbers we got for that. For the coding, we found that the theoretical off-axis field was 2.7006 times 10 to the negative 5 Teslas, and the experimental off-axis field was 6.34717 times 10 to the negative 5 Teslas. There is an 80.61% difference, and B at 45 degrees, and that distance C was this vector. So this is some of the more important parts of the coding. It is how we found the axes and the observations for the perpendicular axes and the vectors, and how we set that up, and then how we did the arrows for the magnetic fields perpendicular to the axis, and then also how to visualize magnetic fields and the codes that we did for that. This is some of the results we got. So to the left is the picture with all the different arrows showing the magnetic fields, and then on the right is the answers we got for the different vectors and the distances. Some of the observations was that at a very large distance, the magnetometer measured a value close to 0 for the x direction magnetic field. The distance in the magnetic field and the x direction have an inversely proportional relationship, meaning when one increases, the other one will decrease. The Earth's magnetic field would interfere with the measurements of bar magnet's magnetic field if the magnetometer was not positioned correctly, which could have been a possible error source, and the model is likely accurate as the magnetic field of a bar magnet is very similar to that of a magnetic dipole. Another possible error source is calibrating the magnetometer. If we got it even slightly wrong, it could throw off our numbers. So to answer the what if, in the experiment, if you oriented your setup so as to compensate for the magnetic north, if we hadn't done that, what could have happened and how would it have changed the results. The Earth's magnetic field would have interfered with the measured values of the magnetic field, and that could have skewed the results. And for the second one, if we had two identical magnets and we redid it, how would we expect them to differ? The measured values of the magnetic fields would have about doubled, but the directions would have remained the same. Thank you.